Physics. A deep dive. Physics is the foundation of our understanding of natural phenomena, from the tiniest subatomic particles to the vast cosmos. Below, we explore its domains with precision. 1. Mechanics. Mechanics explains how objects move and interact under forces. Classical mechanics. 1. Newton's laws of motion. 1. Law of inertia. A body remains at rest or in uniform motion unless acted upon by a force. 2. F equals ma. The force acting on an object is equal to its mass times its acceleration. 3. Action-reaction. For every action, there's an equal and opposite reaction. 2. Applications. 3. Orbital dynamics. Kepler's laws of planetary motion. 4. Engineering designs like bridges and skyscrapers. Lagrangian and Hamiltonian mechanics. 1. Lagrangian mechanics. Based on the principle of least action, S equals L dt. S equals int L dt. S equals L dt, where L equals T minus V. L equals TV. L equals T minus V. 2. Hamiltonian mechanics reformulates dynamics using energy. H equals T plus V. H equals T plus V. H equals T plus V. Relativistic mechanics. 1. Time and space are not absolute. Time dilation. Delta T equals delta TO1 minus V2, C2. Delta T equals frac delta T underscore 0 sqrt 1 V squared C squared. Delta T equals 1 minus V2 C2 delta T 0. Length contraction. L equals L01 minus V2 C2. L equals L underscore 0 sqrt 1 V squared C squared. L equals L01 minus V2 C2. 2. Electromagnetism describes electric and magnetic fields and their interplay. Maxwell's equations. 1. Nabla dot operator A equals V0, Nabla, C dot, math BF, A, equals, frac, rho, epsilon underscore 0, Nabla dot operator A equals A0 rho. Electric fields diverge from charges. 2. Nabla dot operator B equals 0, Nabla, C dot, math BF, B, equals 0. Nabla dot operator B equals 0. Magnetic monopoles don't exist. 3. Times A equals minus B partial differential T, Nabla, times, math BF, A, equals, frac, partial, math BF, B, partial T, times A equals minus T partial differential B. Changing magnetic fields induce electric fields. 4. Times B equals mu0 J plus mu0 A0 partial differential T, Nabla, times, math BF, B, equals, mu underscore 0, math BF, J, plus, mu underscore 0, epsilon underscore 0, frac, partial, math BF, A, partial T, times B equals mu0 J plus mu0 A0 T partial differential A. Changing electric fields induce magnetic fields. Applications. 1. Electromagnetic waves, light, radio waves, X-rays. 2. Electric circuits, motors, and generators. 3. Quantum mechanics. Quantum mechanics explains the behavior of particles at the atomic and subatomic scale. Key principles. 1. Wave-particle duality. Particles, e.g., electrons, exhibit both wave-like and particle-like behavior. 2. Superposition. A particle can exist in multiple states until measured. 3. Entanglement. Two particles remain correlated regardless of distance. Important equations. 1. Schrödinger equation. I partial differential psi partial differential t equals h caret psi I, h bar, frac, partial, psi, partial t, equals, hat, h, psi I partial differential psi equals h caret psi. Describes the quantum state, psi, of a system over time. 2. Uncertainty principle. Delta x delta p is greater than or equal to h2, delta x, delta p, GEQ, frac, h bar, 2, delta x delta p is greater than or equal to 2h. 4. Thermodynamics and statistical mechanics explores heat, work, and energy transfer in macroscopic systems. Key laws. 1. First law, delta U equals Q minus W, delta U equals QW, delta U equals Q minus W. 2. Second law, entropy always increases in isolated systems. 3. Third law, as t right pointing arrow 0 t to 0 t right pointing arrow 0, S right pointing arrow 0 S to 0 S right pointing arrow 0. Applications. 1. Understanding blackbody radiation, basis of Planck's quantum theory. 2. Heat engines and refrigerators. 5. Relativity, special relativity. 1. Introduced by Einstein in 1905. 2. Central concepts, A equals mc2 E equals mc squared A equals mc2, time dilation, and relativistic velocity addition. General relativity. 1. Gravity is the curvature of space-time caused by mass energy. 2. Equations, Gmn plus lambda Gmn equals 8 pi Gc4 Tmn G underscore mu, nu, plus lambda G underscore mu, nu, equals frac 8 pi G C caret 4 T underscore mu, nu, Gmn plus lambda Gmn equals C48 pi GTmn. 3. Verified by gravitational lensing. Detection of gravitational waves, LIGO, Virgo. 6. Particle physics, the Standard Model. 1. Fundamental particles, quarks, leptons, gauge bosons. 2. Higgs boson provides mass to particles. Beyond the Standard Model. 1. String theory, supersymmetry, and quantum gravity aim to unify physics. Space sciences, a deep dive. Space sciences rely heavily on physics to understand celestial phenomena and the universe. 1. Astronomy, stellar evolution. 1. Birth, stars form in nebulae due to gravitational collapse. 2. Life cycle, main sequence phase, nuclear fusion of hydrogen. Red giant or supergiant phase. 3. End states, white dwarf, low mass. Neutron star, medium mass. Black hole, high mass. Exoplanets. 1. Detection methods, transit, light dips. Radial velocity, wobble. 2. Astrophysics, galactic structures. 1. Spiral galaxies, e.g., Milky Way. 2. Elliptical galaxies, massive, older. 3. Dark matter, explains missing mass in galaxies. High energy astrophysics. 1. Black holes and accretion disks. 2. Gamma ray bursts and quasars. 3. Cosmology, Big Bang theory. 1. Universe began 13.813.813, 8 billion years ago from a singularity. 2. Evidence, Hubble's law, V equals h0 dV equals h underscore 0 dV equals h0d. Cosmic microwave background, CMB. Dark energy. 1. Accounts for accelerated expansion of the universe. Fate of the universe. 1. Big freeze, stars exhaust fuel. 2. Big rip, dark energy tears apart space-time. 4. Space exploration. 1. Achievements, lunar missions, Apollo. Mars rovers, Curiosity, Perseverance. Telescopes, Hubble, James Webb. 2. Future goals, Artemis program, lunar colonization. Mars missions, human settlement by SpaceX. This breakdown provides a strong, interconnected overview of physics and space sciences. Let me know which part you'd like to explore further or clarify.